Hey, just want to start off by explaining a little bit about myself. This is Ian Smith. I'm a junior UT studying IT engineering, and I hope the rest of this class prepares me for the rest of my career. Okay, let's start off today. Learn a little bit about object-oriented programming for our midterm. Overview of what I'm talking about today is going to be introducing a couple concepts of computers and programming and Java in general, followed by learn a little bit about elementary programming, the basis of programming, and follow that by selections and how they're used in programming, and sum it all up with mathematical functions, characters, and strings, and how they're also used in programming. So here we go. Introduction to computers, programming, and Java. So before we start off about talking about programming, we gotta first figure out what is a computer. Well, a computer is made up of several components that actually make it a computer. And to start would be storage devices. Storage devices can be anywhere from disk drives, which are hard drives and floppy disk drives, and USB nowadays. Floppy disks are more ruled out. Every computer has a storage device, and storage devices are used to move your storage that's permanent and move it to memory when it needs to be used. Now, memory is used, or also is called RAM, random access memory, and this is used to store information or instructions that your computer needs to execute. And the CPU is the device that executes these programs. Something that needs to be known for memory is ordered in a sequence of bytes, and each byte holds 8 bits. It's very important. Now we move on to CPU. CPU stands for Central Processing Unit, and it's like the brain of the computer. Speed is measured in gigahertz, and your normal processor usually is around 3 gigahertz. Moving on, we have communication devices, which in other words can be used as, or called anything that helps you connect to the internet, such as a modem, network cards, such as that. Moving on, we have your input device. Everyone knows what input devices are. Your input devices are going to be your keyboard, your mouse, anything that would plug into your computer and create an input. And your output devices, everything has to have an output. So your output devices would be your monitors, your printers, displays your output or prints out your output in some form. And those are all the devices that are used to make up a computer. Moving on here, we're going to go over and head over to writing and compiling programs. Writing and compiling programs. A few key things you need to know when you're writing or compiling programs. And starting out, it's going to be class names. Now, every program has to have at least one class, and that class has to have a name. And that name has to be usually capitalized. Well, it is capitalized. The next thing, main method. Every program has to have a main method. This is actually needed in order for a program to run. A program's always executed from the main method. Then you have your statement. Your statement is actually what's being done in the program, the actual job that's being carried out. And there can be multiple statements in one program. So that's why you need a statement terminator. Statement terminator is are used to end statements. They're usually represented in semicolons at the end of each statement, and it keeps the statements separated and keep you from looping your statements or keep your program from not working at all. Moving on. Also, when writing and compiling programs, you have reserved words. Now, these words are already predefined in Java. They're inside their packages. I guess they've already been written into code into their programming. Um, as soon as you type these words in, a color will appear, and you'll know right away that these words are um, reserved words. And these words cannot be used for any other purpose than their own purpose. For example, the word class is actually obviously a reserved word because it represents the class. When you type in a class, the program is going to be looking for the name after class. That's why obviously you can't use them. Moving on, we have comments. Now comments are represented with 2 forward slashes, and they are used to help people help you make the the program a lot easier to understand. Usually use it before a big um, class or anything that's to be defined, and you also use it at the beginning of the program describing what your program does. It's usually the main use for it. Last but not least, blocks. Blocks, these can be represented in multi ways: brackets, braces, and they group components of programs together. For example, braces group classes together, and they also group methods together. I mean, they're used the same symbols used, just they're used separately to keep things organized. Also, without these, your program would not run correctly, and you'll most likely get an error. Moving on. There are various ways to compile code nowadays. They're more popular and least popular. Today, I mean, you have text editors, Word documents that can compile code, and they have, independent programs such as NetBeans and Eclipse that have integrated development environments or IDEs built in. Some they don't utilize the user side of the programming aspect, which are more you're going to see in your text editors and Word documents because they don't have an actual screen that displays the output or the user input. Me personally, I prefer to use NetBeans or mainly any other software with integrated development environment or IDE already integrated. It just makes things a lot easier. Your things show up in different colors. Your words show up in different colors, whether it's um, it's a defined already word. Um, just keeps everything neat, and also you can see the user side of it, so it's easy to edit your program when you make mistakes and see both sides of it. Another reason why I would like those type of software is because they're open source, which means you can edit it and change it as much as you want, and best of all, it's free. Here it just goes through, shows you the different types, and there's NetBeans, the one I currently use. It's recommended, and into elementary programming. Things to consider when programming. Brings me back to this list. You definitely want to consider your class name. You want to name your class with a capital letter, and as soon as you put class, it's going to be looking for a name. So make sure you don't use class for any other use besides defining a class. Your main method. You're going to use your main method every time, just like your class name. Your program is executed in your main method, and you're going to have your statements. They actually what makes your program run. So you're obviously going to need those to run your program, and you want to make sure those statements are correctly worded and correctly typed with the correct um, statement terminators for one at the end of each statement, so your statement would end. Also, reserve words, you want to make sure you use those in the appropriate way, like I specified earlier with classes. Um, your reserve words are already predefined in Java, so you don't want to use them for any purpose and for what they're used for. Um, comments. You want to use comments religiously. Use comments to define your whole program, and just so people would know when people go back and edit your program, they'll understand and what you were doing step by step. As long as you comment on every line and make sure you put 2 forward slashes before every comment. You can also comment in big portions of your text by inserting a forward slash and an asterisk, and then at the end you insert an asterisk and a forward slash to combine the whole comment. One last thing would be blocks again. You want to make sure your blocks are in correctly. You want to make sure you're not putting braces when you need brackets or vice versa. Um, it just would just screw your whole program up. And another thing to keep in mind of is errors. Errors, they're going to happen. It's just you got to know when and what type of error it actually is. It's like syntax error and runtime error and logical error, where a logical error is an error where you have your calculations wrong on your program, and a runtime error would be uh, something not executing while your program is running, and a syntax error could be just as simple as having your blocks off wrong, your braces, and you want to make sure those are in the correct spots. Next I have software development process. So developing software is a tedious task and involves a lot of engineers and involves a lot of just time basically. I'm gonna go through these and start at the top. I mean, requirement specs, specifications. That's making sure your program is doing what it's supposed to do. I mean, you want to make sure that you wrote that program to do a certain task. You want to make sure that task is being accomplished. You have your system analysis. This helps to identify inputs and outputs, and it determines what you want and the outputs, and it helps construct the input. So basically, when you figure out what your output needs to be, it's way easier to construct your input, and that's kind of done through system analysis. You have system design, which is the output, basically having it the way you want it, having it organized, having it formatted correctly when the output comes out. You don't want it looking sloppy and messy, and someone makes fun of your programming. Continuing, you have implementation, which is different programs written separately and combined to work together. I mean, they're being implemented. A lot of programs are written separately because they're written um, as huge documents, um, as compared to the ones we're using now. Um, keep it going. Testing, obviously testing. It ensures there's no flaws or no bugs, and making sure that everything's flawless right before you move to the next step, which is deployment. And that will be making the software available and compatible to anyone, to the public or whoever department you're releasing it to, or field. And after it's released, you always have to take care of the maintenance on it. Who likes to get in a car and brand new car and them not maintaining it for for a certain amount of miles? The same way. Yeah, you want it maintained correctly. I mean, you get a program and you want to make sure it's updated constantly, it's improved, and people are debugging it. It's not just submitting it. It always needs to be updated and make sure everything's working correctly. So now we'll move on to giving a little explanation of how to write a program. So here's a good example of how to write a program, and this is program with selections. Is an if statement, an else statement. In this program, it's a little bit more simpler, so there's no, I have this portion of it, so I don't have the class obviously stated, but the if statement, this program reads, if the radius is less than 0, then basically system prints out incorrect input. And the else statement, which means if it's greater than 0, the area equals radius times pi. System output is going to print your area is whatever your number, calculated in, and that's which equals the area. And on the console, it's going to print out either incorrect input or whatever your area is, as whatever calculated through the input you put in. And selections. Before I move into selection, I just want to say that I've programmed before, and it was with Python. And I can easily say that Java is way better programming software. It just works for programs of all sizes, unlike Python. Just more real-world programming software that you can use for anything, and it's just good practice to do. And I feel like you can make your life a lot easier if you learn how to program with Java. Another reason why Java is pretty good is it actually is multi-platform, so you can learn this and learn how to program for smartphone devices or tablets, you name it. I mean, the sky's the limit at that point. Now moving on to if-else statements. Let's go a little bit deeper. The if just means basically do this if your function is true, or the equation is true. If it's not true, then you obviously have to have some kind of statement that stops it, or it's not going to run. Then you have your if-else statement, which is, if this is true, then go through the if statement. If it's not true, then else. Do the other thing that was described in the program, like as stated right here. If the radius is less than 0, that's the statement you're gonna output incorrect input. Else, display the area. So it helps make it a little bit easier when explaining selections. Now we're going to move on to mathematical functions and characters and strings. So mathematical functions are used to make everyday issues easier, like programs to compute tax, or have one here, or even simple ones to guess your birthday. You can create anything with mathematical functions. Your area, I just showed area. On the characters, actually we'll move on to strings first. Strings are used to display characters onto the console. They can easily be combined or concatenated. Concatenated meaning they can be obviously combined. They can be put together. It's just an easy way to get a group of letters together without ruining your program. Characters, they're like strings, but only useful for one letter. Not really useful if you're writing a big program and you need to designate with letters. Wouldn't use that.